Right, this lesson here with Uncle Kev is going to be on diagonals, length of diagonals. So we'll put that down here, length of diagonals. Now, why is this important? It's actually very important when you're setting out a building. When you're setting out a site, you arrive up on a site and there's some boundary pegs here, here and here, and then you're going to have your plan, and your plan's going to tell you to keep 2 metres away from there, keep 5 metres away from here, and then we've got to, 1, get that nice and square, and 2, we need to know the diagonals so we can scribe an arc there, scribe an arc there, and we can get some accurate measuring going on around here and get a nice square build on our site. And that's going to be so that's very important for setting out a building and getting things square, and that's real critical. So once again, we've got a formula, and our formula was a squared plus b squared equals c squared. Now this formula was done by a guy called Pythagoras. Pythagoras is an old Greek mathematician from way long ago, about 500 BC, which is currently we're in 2020, so it's 2,500 years ago was this Greek mathematician, and he came up with this formula, a squared plus b squared equals c squared. So we have to unpackage that a bit first. So here's the triangle here, right, and then we've got side A, side B and side C. So that's where Pythagoras come in and said a squared plus b squared equals c squared. Now have we got any questions at that point? Rodney, have you got a question? Oh yeah, Uncle Kev, I had a question. It's all right having a triangle, but what's these A's and B's and C's? Which way do they go? Because I get confused on here on which way the A's and B's go. Right, can you explain that? Now that's a very good question, Rodney. Sure, A plus B equals C squared, but with a triangle, we've got to have a right angle here. So we've got a right angle here. Now the A and the B, either side of the right angle is fine. That's like two wee arrows pointing to A and B. C is called the hypotenuse. Hypotenuse, and C is always the long side, which is opposite to the square. So it doesn't matter if our triangle's that way or our triangle's this way here. Which is the square corner? This one here, shown by that. A, B, C. C's got to be this one. Either of those two could be A or B. So that was a good point to make. Alright, so we've got to unpackage that a wee bit. We need to know two things. Point one, squared. What squared even mean? Well, squared is something times itself. So if we want 3 squared, 3 times 3. 3 threes are 9. So 3 squared equals 9. 5 squared is going to relate to 5 times 5 equals 25. So when you square something, it's times itself. So when Pythagoras told us to square A and B and that equals C, then that's covered off A and B. Now the trickier bit is for finding out, and this is where we use that there symbol is for square root. Square root. Now what's square root? Square root is when you've got a number and you have to find out what times what equals it. So if we picked a number like 100, so if we put 100 here, what times what equals 100? So that's where on the calculator we could go, and there's a square root button on the calculator, square root of 100 equals 10. So we can put 10 there. So we know that 10 times 10 equals 100, and that's the square root of 100, is 10. but you're often not going to have a nice even number like 100. You might well have a number like 76. So what's the square root of 76? Same deal, put it in here. Square root 76 equals 8.718. 8.718. So now we know that the square root of 76 equals 8.718. Okay, so that's where we've got our square root, comes through from here, and then our a squared plus b squared. With this Pythagoras' theory, a squared plus b squared equals c squared, because we've got modern calculators that don't require brackets and we can simplify it by a step, we'll do a modern formula, and our modern formula will go like this. Square root of a squared plus b squared equals c squared, which will be here. So that'll be our answer there. A squared plus b squared. So we can do that. Now for example, here's a triangle, 9 metres in height, 13 metres in width, square there. Doesn't look very square, keep. Square there. Now we need to find out what that is. So we'll use our formula, which is simplified by our square root here. So we're got a square root button on our calculator. Square root of 9 squared plus 13 squared equals, and I get an answer of 15.811. So there's our answer there. If we had a triangle 9 by 13, that equals 15. Now another way to show this, if we change those numbers around, we've got this same formula, but we've got an easier way to show it. If that is like 3 and that there is 4, what's this one here? Now this is how you get a standard 3, 4, 5 triangle. If we divide that into 3 squared equals 9. There's 3 squared, 1, 2, 3, 1, 2, 3. This one here is 4 squared. 1, 2, 3, 4. 1, 2, 3, 4. 4 squared. So we've got 4 squared there, 3 squared there. We can add those squares up. So there's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25. So 25 is equal to 5 squared. 2, 3, 4, 5. There we go. So there's our old standard for setting out 3, 4, 5 triangle right there. 3 metres, 4 metres, 5 metres, or you can even use multiples of that. It could be 6, 8, 10, or 3 times 8, 24, 4 times 8, 32, 5 times 8, 40. So any of those would work, any multiples of 3, 4, 5. And that all relates back to our formula here. We'll do another example, just so you get a good handle on it. Now say that's 11 metres 365, and say that's 6 metres 111. What have we got here? Here's our formula. Square root of a squared 6.111 squared plus 11.365 squared. We'll do that on the calculator. Square root of 6.111 squared plus 11.365 squared equals, here's our number here, 12.904. We went around in there. So now we know for that to be nice and square, 6.111, 11.365. We would have got those dimensions off a plan, and now we know that our hypotenuse would be 12.904. Thank you.